Hello, everybody, and welcome to Jaeger Deep Dive project session. This is the second presentation at Cloud Native Con Virtual. The first one is Jaeger intro, and if you haven't seen Jaeger in action, I encourage you to watch the recording. I'm pretty sure there is a very nice demo of Jaeger in action. So in this talk, the agenda is we'll talk about the project in general. Then I will spend some time talking about how tracing works under the hood. We'll have a look at two concepts. So I'll explain how the data collection works inside your application, but also how the tracing infrastructure works under the hood. Then we will jump through a couple of different topics, namely sampling, Jaeger integration and architecture, and Zipkin compatibility. And last but not least, we'll spend some time talking about new features since the last KubeCon, something about roadmap, and finally, we will do Q&A. So just briefly about myself, I'm Pavol Loffay. I'm a software engineer at Red Hat, and I have been working on Jaeger since basically it has been open sourced in 2017. And apart from Jaeger, I contribute to a bunch of other projects that are distributed tracing related, namely OpenTracing, microprofile OpenTracing, and also OpenTelemetry project. So Jaeger is a distributed tracing platform. It's not just a single server that you run on your laptop or as a deployment. It's much more than that. It's the whole ecosystem of different components for different purposes. So on one side, there are instrumentation libraries or SDKs that run inside your application, and they collect data and they report it to the tracing collection backend. On the other side, there is a visualization or the user interface that we use to see our distributed transactions. And in middle, there's also a data mining integrations and platform that is used to aggregate the data and derive another interesting insights from the data what we collect. So Jaeger as a project, it's inspired by Google Dapper and OpenZipkin, and it's mainly because it uses very similar data model as these two systems use. It has been created at Uber in August 2017, and 2 years later, it has been open sourced in 2017. The same year, it also joined CNCF Foundation as an incubating project. And last year, so basically, again, 2 years later, it graduated to top-level CNCF project. So from the technology stack, Jaeger itself is written in Golang, and it's a very pluggable system for storing data. So with the upstream project, we directly maintain implementations for Cassandra, Elasticsearch, Badger, and in-memory for demo and test purposes. But the storage layer is pluggable, but is also quite simple to implement. So if you have expertise in running different storage, it's very simple to implement storage write and query interfaces. The UI is React.js. It's very nice UI. You will see that in a Jaeger intro. And the collection libraries or the SDKs, they implement OpenTracing API, and they are available in many languages. So for example, in Go, Java, Python, Node.js, C++, C#, PHP, and Ruby. Jaeger also integrates with Apache Kafka and Flink and Spark for streaming and data processing. We will see that more in architecture. So as a community, Jaeger is hosted on GitHub under Jaeger Tracing organization. The main repository has roughly around 11,000 stars. And there is about 1,700 contributors across all repositories inside the main organization. There is roughly 15 maintainers, again, across all the components that are in the organization. We do have also a Twitter channel and a Gitter channel, well, where you can ask questions or raise problems. And we always try to help our users to resolve issues and help them to get started with Jaeger. We do release roughly every 1 to 3 months. We always try to release once we have reasonable set of new features. And Jaeger itself is distributed as a set of Docker images, but also as a set of binaries that you can get from the GitHub release page. So how Jaeger works, but more in general, how tracing works under the hood. So on this diagram, we see a bunch of stuff, right? But basically, there are 2 important pieces here. On the top, there are 2 microservices, so our standard applications. And on the bottom, there is tracing infrastructure. And we see these microservices that they embed tracing API and tracing library. So the tracing API is something that the application uses to report tracing data, to create events. And the tracing library is the implementation of this API that reports data to the tracing system. Now, if we zoom in into the application, we see that the application consists of different layers. There is some inbound layer, then there is some, something in the middle. So, for example, business logic, and then there is the outbound layer, which can be, for example, an RPC layer to the next service. And every layer talks to tracing API. And we call these points trace points. So these trace points, they report tracing data via the tracing API. And so with these trace points, we call them also instrumentation. So instrumentation is just a piece of code that basically emits tracing events based on the behavior of the application. This is a little bit different to metrics and logs because tracing is stateful, so it carries some context with it. So when a request arrives to the first microservice, what tracing API does, it will create a special context with unique IDs. These IDs are also generated by the tracing API. Now, this context is propagated to all downstream instrumentation points and all downstream microservices. The context doesn't change. And this is important because the context doesn't change because all these events will have the same IDs. So later, the tracing system can correlate all these events together and reconstruct the full trace or the execution flow. And so the context propagation, it's basically the foundation of distributed tracing. So let's have a look at the tracing infrastructure itself. So once the data leaves the tracing library, it goes usually to a collector or agent that stores data to a trace storage. Apart from trace storage, there is also some data mining and the presentation layer. So let's have a look at how the tracing works with OpenTracing and Jaeger. So OpenTracing and Jaeger, many people, they use these technologies interchangeably, but actually there is a clear difference between these two. So on this diagram, we see again on the top the application or the process, and on the bottom the tracing infrastructure. The application, we see that it's instrumented in two different ways. It uses the manually instrumented frameworks and automatic instrumentation. So manually instrumented frameworks, this is just something like a library that you can pull into your class path, and it will emit tracing events. And automatic instrumentation is, for example, Java agent that does bytecode manipulation to instrument your application. So all these instrumentations, they basically use just OpenTracing API. And then the tracing library implementation, in this case Jaeger, just implements this API and reports data to the agent or collector. So the tracing API is important because there are so many trace points in our application. And so if we wanted to change the implementation and we haven't used the API, we do have to change all of those calls to the tracing API. So the tracing API basically abstracts the implementation, which makes it easier for us to switch the implementation, which is very important. However, with OpenTracing, there is one slight problem, is that if you want to change the implementation, we have to recompile and redeploy our applications. So once we look at the bottom, there is agent and collector. So the library that lives in our process reports data to the agent or collector, and it can choose where the data will be reported, right? The difference between agent and collector is that agent lives very close to the application. So it's something like sidecar container, or it lives on the same host as the application process. Then the data goes to collector, and collector just stores the data into storage. Now let's have a look at the OpenTelemetry versus Jaeger. So we see the OpenTelemetry is also the instrumentation API, but it's also the tracing implementation. And this has a couple of advantages over OpenTracing, because now if we want to change the implementation, we don't have to recompile and redeploy our application, which is a big plus. What is maybe confusing on this slide is that OpenTelemetry is also the agent and the collector. So this is a new component in OpenTelemetry, which is called collector. And collector is a component that can receive the data, can process it, and then can send it to the other systems. So difference between Jaeger collector and OpenTelemetry collector is that Jaeger collector is also able to store the data in a storage. So let's have a look at sampling. So sampling is a technique how we store less data that we actually receive. And there are basically two approaches how to do sampling. The first one is coherent head-based sampling, and the other one is tail-based sampling. The coherent head-based sampling means that the sampling decision is made when a request first time reaches our infrastructure. And so we make the decision, and then the decision is propagated to all downstream services. And these services, they have to respect the decision that has been made at the beginning. And there are two implementations how we can sample at the head. The first one is probabilistic, and the second one is rate limiting. Probabilistic basically says, for example, sample only 1% of all the requests what you receive. Rate limiting says, for example, sample only 10 requests per time unit. So, for example, 10 requests per second. Sampling is usually configured per service. And so this is a problem because some services, they receive a lot of traffic at some endpoint, but other endpoints might receive very low traffic. And if we use a single sampling configuration across all those endpoints, the endpoints with low traffic will pretty much not be sampled at all. So Jaeger allows you to configure tracing also per endpoint level to solve this problem. The other feature what Jaeger provides is centrally controlled sampling. And so in Jaeger, there is a configuration file where you can configure all the sampling strategies, and this configuration is then pushed to Jaeger clients reporting the data. And so the other approach to sampling is tail-based sampling. Jaeger at the moment doesn't do tail-based sampling. It is something that we are looking at, and I will talk about it in the roadmap. So integrations. Jaeger integrates very well with Kubernetes. There is Jaeger operator and Helm chart. So the operator is a component that can deploy, but also manage and upgrade your applications. So it's much more robust way of deploying business application into Kubernetes. If you want to use plain Kubernetes manifest, Jaeger operator can be used as a CLI tool to just generate this manifest based on the configuration you provide to the operator. The next integration is with Prometheus. So Jaeger server and all the client libraries, they report metrics in Prometheus format. The OpenTelemetry integration, all the OpenTelemetry clients or SDKs, they ship with Jaeger exporter. So you can use OpenTelemetry SDKs with Jaeger backend. An OpenTelemetry collector ships with Jaeger receiver and exporter. From the service mesh, Linkerd and Istio, they come with Jaeger as a standard tracing system. And Envoy uses native Jaeger C++ client. So let's have a look at architecture. So when Jaeger was introduced, this was the default architecture. So on the left side, there is the host and container, so our application, reporting data to the collector, and then collector was storing data to storage, which then Jaeger query was using to get the data for the user interface. The data processing was done in batches, so Spark job was reading the whole indices and tables from database. It calculated some results and stored them back to storage. And so this architecture had a couple of problems, especially with scalability and traffic spikes. So if there was too much data going to the collector, the storage couldn't keep up, so we just dropped the data. And also, we couldn't calculate sometimes the aggregation. We couldn't run the aggregation jobs because there was just too much data in the database, and it was very resource heavy to run the Spark jobs because they had to pull a lot of data from the database into memory. So to address this problem, we introduced Kafka that sits between the collector and storage. So collector, instead of writing to database, it writes data to storage. And then there's ingester that just reads data from Kafka and pushes them to database. This allows us to run streaming jobs. So instead of batch jobs, that basically these streaming jobs, they connect to the same topic in Kafka and push data or push results to storage. So Zipkin compatibility. So Jaeger is fully compatible with Zipkin. It can ingest Zipkin data in pretty much all the formats. And it can also read Zipkin data from Kafka. From the client side, Jaeger clients, they understand Zipkin context propagation protocol v3. So you can use Zipkin instrumented applications with Jaeger's instrumented applications. So what is new in Jaeger since the last KubeCon in North America? So we have done a lot of progress. There has been a lot of new features, a lot of bug fixes, and a lot of stability improvements. So one of the major features is data loss statistics from clients. So Jaeger clients, they can drop data. It's obviously a problem when the clients drop data. They drop the data because they want to keep a reasonable quality of service. They don't want to overwhelm the backend. And so this is a problem, but it used to be a bigger problem because we couldn't tell how much data the clients are dropping. So now there is a way how clients can notify the backend how much data they dropped. We have also done a lot of security improvements. So for example, Kafka basic authentication and TLS for query service. And also Jaeger operator, it's able to automatically provision certificates, but also renew them if they expire. From the usability standpoint, we compiled and we distribute Jaeger for different architectures. So apart from Linux and Windows, we added ARM 64 and PPC 64. The next topic is TraceDSL, and this is something that I was personally really excited about, and I worked on this. So we wanted to make it easier for data scientists and DevOps people to basically run programmatic queries against Jaeger. And to make this possible and simple, we developed a TraceDSL, a trace domain-specific language that is able to query data, but also extract features from the data. And so this DSL is used in Jupyter notebooks that connect to Jaeger query, but also to Kafka for streaming processing. And so the main use case for this is that sometimes if you want to verify your hypothesis, the verification requires aggregating a lot of data, and this is just not possible in a UI because you cannot aggregate or you cannot manually investigate thousands of traces in a user interface. To really run such an investigation, you have to write a piece of code that will do it for you. The next new feature is trace quality metrics. So the same repository with the TraceDSL, it also provides some support for metrics. And these metrics basically says how well are your application instrumented. So this is very crucial because if your environment is not well instrumented, you will not get the full power of distributed tracing. And the last new feature is rebase on OpenTelemetry. So we have basically rebased all Jaeger backend components, agent, collector, ingester, all in one, on top of OpenTelemetry collector. So all these new components are basically OpenTelemetry collector, and we just added storage functionality to this new component. So on this slide, you can see the configuration of new Jaeger OpenTelemetry collector. And what is different to the upstream OpenTelemetry is that these components can store data to storage. So we see the section with exporters, and there we see Jaeger Elasticsearch. And we see that Jaeger Elasticsearch, which is just, it's the standard Elasticsearch configuration. And to make this very simple, we have made a couple of decisions to support simple upgrade from the current Jaeger components to this new set of binaries. And so we support the current Jaeger configuration. So you can also configure this new component with the current Jaeger flags and current Jaeger configuration file. There's a lot of remaining work. If you're interested to participate or see the progress, you can subscribe to Jaeger Tracing /Jaeger repository and watch for issues tagged with aria/auto. Okay, so what is on the roadmap? So we will continue with integration with OpenTelemetry. And once OpenTelemetry collector reaches GA, we will release this new set of components based on OpenTelemetry collector. And we are also looking at scalable tail-based sampling from OpenTelemetry. If you want to learn more about Jaeger, there is jaegertracing.io website, but also blog on the Medium, where we publish interesting topics related to Jaeger, but also to tracing in general. If you want to get in touch, the best place is probably the community channel, but also GitHub and mailing list. We also do bi-weekly community meetings where you can connect and talk to us in person. Okay, this is everything what I have prepared for today. And if you have any questions, feel free to ask them in chat.